spacecraft that spent nearly 14 years orbiting Earth was expected to make its final return to the atmosphere around yesterday, March 10th, 2026. But here's the interesting part. We don't have to rely only on headlines to understand what's happening. We can actually verify spacecraft like this using real satellite tracking data. Let's take a look. Hi everyone, I'm Dr. Amanda Fetch, and welcome to Tech AI Space MI. On my channel, I break down what's happening in space, and more importantly, how we know it's happening using real data. Today we're looking at the predicted re-entry of NASA's Van Allen probe A. According to an article from NASA titled NASA's Van Allen probe A to re-enter atmosphere, the spacecraft was expected to re-enter Earth's atmosphere about 14 years after the launch. Now, the spacecraft launched in August of 2012, along with its twin spacecraft, Van Allen probe B. And this was done to study Earth's radiation belts, which are rings of charged particles trapped by Earth's magnetic field. These radiation belts help shield Earth from cosmic radiation and solar storms that can damage satellites and other technology. NASA reported that the spacecraft was expected to re-enter the atmosphere again around yesterday, March 10th of 2026, with an uncertainty window of about plus or minus 24 hours. Most of the spacecraft was expected to burn up during re-entry, and the risk to people on the ground was extremely low, something like about 1 in 4,200. So how do we actually verify this spacecraft and its orbit? Scientists track satellites using a global catalog maintained by the United States Space Force 18th Space Defense Squadron, and which is accessible through SAIC and spacetrack.org. This catalog tracks objects launched into orbit. Using information from the NASA article as well, specifically that launch date of August 30th, 2012, we can search that catalog for objects that were launched on that date. So when I pulled the data, again from spacetrack.org, when I checked the catalog, on March 11th, 2026, today, the search returned 3 objects from that launch: RBSP-A, RBSP-B, and Atlas V Centaur rocket body. Now that's an important detail. Tracking systems monitor not only satellites, but also rocket stages and debris left in orbit, which again was what my research had been based on. Now the RBSP designation stands for Radiation Belt Storm Probes, which was the original mission name before NASA renamed it the Van Allen probes. So RBSP-A in the catalog corresponds to Van Allen probe A. Once we identify the spacecraft in the catalog, we can look at its orbital parameters. So for RBSP-A, the catalog shows a perigee, the lowest point in the orbit, of about 117 kilometers. That's considered extremely low. The upper atmosphere begins around 100 to 120 kilometers. So at that altitude, atmospheric drag increases rapidly, and a spacecraft can no longer maintain orbit. This is why the spacecraft was expected to re-enter the atmosphere. According to the NASA article, scientists originally predicted the spacecraft would re-enter around 2034. But the current solar cycle has been much more active than expected. Solar activity heats and expands Earth's upper atmosphere, increasing drag on satellites and causing them to fall back to Earth sooner than predicted. Even though the mission ended in 2019, the data collected by the Van Allen probes is still incredibly important. Scientists continue analyzing these measurements to better understand space weather and how solar activity affects satellites, astronauts, and critical systems like communications and navigation on Earth. Now I'm curious to see what you think. As we launch more and more satellites into orbit, should spacecraft be designed with controlled re-entry systems to reduce debris and improve safety? Let me know what you think in the comments. And if you enjoy breaking down space events using real data, don't forget to subscribe to Tech AI Space MI. Take care. Thanks for tuning in.